Yeah, so don't worry about the ones that weren't assigned up there, but like I said, I just didn't update my answer key. Other questions? The percent was okay? Any questions, guys? Okay, so again, doing our last notes of the chapter today. I'm going to tell you guys, this is typically one that's a little bit tougher for some students because it's a little harder to see kind of the purpose. I mean, it has a purpose, but it's harder to like connect it right now. So I will warn you guys about that. So a little bit tougher problem there, like problems today. But hopefully we'll get you guys through it. So far it seems like you guys are doing pretty well in this chapter, so hopefully it'll go okay. There is a warm-up question there for you guys. Get them like right between like my fingers, like the webbing on my fingers. That's like my paper cup place that I end up hurts so bad. And then I forget, and then I put hand sanitizer on, and I'm like, again, this is a little bit tougher section, so I just ask that you guys ask questions as we're going through it. If you get stuck on something or if you're not understanding something I'm suggesting, it's really not supposed to be all that like kind of out there, but it's just a harder one to wrap your mind around. So let me know if you have questions at all if you're going through it. You guys could take a minute to look at that warm-up question if you haven't already. Solving for x here, so just remind you guys of those fraction problems. I don't think we can ever do enough practice with fractions as much as we don't want to. It's not something that like just jumps out at you as like, ooh, I love those problems when those come up. So I think it's good practice. I know sometimes practicing things that we're not good at, it's frustrating. So, but definitely something we need to do. So we want to solve for x. So hopefully we all agree on our first step here. What do you do first? You added 4. So get that 4 away. because the 4 is not part of the multiplication. So we can move that 4 over. And so now we have 9 equals 2/3 x. So how do I get rid of that 2/3? There's probably like 3 different ways we can kind of describe how to get rid of it. What you guys do. Yeah, go ahead.
Multiplying 9 by 3 and see what is the second minus 9.
Yeah, so it's kind of that 2-step approach. I like this one because I think it helps you to see most clearly like how to find your answer. So he said multiply by 3. So we're going to multiply each side by 3. So I get 3 times 9 is 27. And then I'm just left with 2x over here. I think that's a really easy way to see that, like, let's get rid of that fraction. I think that's what he was intending there. And then now we can just divide by 2. So it's kind of a 2-step approach to like a fraction, but I think it's a lot easier to work with than working with like the fraction itself. So now we can just divide by 2. So we find out x is 27 over 2, which is the same thing as like 13.5, right? Now, if you didn't do it that way, if you look, there, like I said, there's probably 3 different ways to solve 9 equals 2/3 x. And I'm okay with any of them as long as you're able to get the answer that we have. I mean, there's not like alternate answers. There's like the one right answer. So any other ways you guys wanted to use that you wanted to explain? Yeah, what'd you do? What's that? Divided by 2 first? Okay, yeah, so that works as well. So she just flipped the order. She divided by 2 first and then multiplied by 3 and you get the same outcome. So that works as well. It's probably a little bit tougher to show, but it works as well. So maybe even 4 ways. Another way is you can just use your calculator and just divide by 2/3. Otherwise, do you remember we talked about multiplying by the reciprocal? Because then those just cancel. So same idea here, I get 27 over 2. So lots of different ways to get that answer. So I'm not picky about how you get there, as long as you show me some steps. When you magically show up from this down to 13.5, I kind of question like how you got there, or kind of the connecting dots in between. Okay? So, like I said, today is not that far off from what we've been doing, but it's a little bit tougher. And for whatever reason, it's just, I guess it's just hard to see like maybe the value in it, because you're not just going to get one answer. You're not going to get just x is 13.5 today. You're going to find out that x is going to equal a few different variables, which is kind of strange. So we're working with an equation, but it's going to have more than one variable in it. So a literal equation is an equation with more than one variable. An equation with more than one variable. You use these equations, or have used these equations before. Anytime someone told you how to find the area of a shape, like the area of a triangle, or the volume of like a box or something, length times width times height. You've heard that formula probably before. So really literal equations are just, a lot of times they can be formulas. So like area equals base times height divided by 2. So that's an example of a literal equation. We call it a formula because that's the formula for the area of a triangle. So that's something you've probably seen before. So what we're going to do today is they're going to say, rather than solving this for A, solve it for B or H, or solve a different formula for X or Y. They're going to ask you to solve that formula, but these aren't numbers, so I can't, I don't know what those numbers are right now, so I'm going to have to just leave them as variables, which again is just strange. So I'm going to give you guys some steps on how to do it. It's really not that different from the steps we're going to use for solving regular equations. It's just there's not going to be a lot of math to do. Or we're not going to be actually probably need our calculators very much at all today. So I'm going to remind you guys that you're going to try to undo what's happening to the variable. So for example, if something's being multiplied, we're going to divide. We're still going to follow the reverse order of operations where we're going to add or subtract first and then multiply or divide. And then finally, just so that you guys, we want to try and simplify as much as we can. A lot of times we won't be able to simplify at all. So simplify only if possible. So we'll do a few examples here. We'll do some examples with whiteboards, making sure you guys are kind of comfortable with it. And then we'll do some extra practice with that. And some word problems. All right, so this first formula is the one I just wrote. This is the formula for the area of a triangle. You don't need to know that that's what formula this is. You don't have to look at that and be like, oh, I knew that was the area of the triangle. It's just kind of just being aware that it's a formula. But notice they want us to solve it for b. That means they want us to get b alone. So this means get b alone. So it's going to be like b equals when we're done, is what we're trying to get. And my b's end up looking like 6s halfway through my problem, so just know that it's a b and not a 6. So the question is what's happening to b in this problem? What math is being done to b? What looks easiest to like undo first? Yep.
It's being divided by 2.
Yeah, it's being divided by 2. Kind of like our warm-up question. We had that kind of division in that fraction. So same thing here. This is being divided by 2. So let me move this guy over. Sorry, you guys can't. So it's being divided by 2. So how do we undo divide by 2? Multiply by 2. So we're going to multiply each side by 2. So we're trying to get that b all alone. So those 2's are going to cancel there. On the left side, I'm going to have 2 times a. Now I don't know what a is. That's okay. I'm just going to leave it as a. And I'm left with bh over here. Everyone okay with that first step? It's all, we just move that 2 over to the other side. Now I'm trying to get b alone. So what's happening to b? It's being multiplied because b is being multiplied to h. So the opposite of multiply by h is divide by h. And again, I'm trying to get the b to be all alone. So that's why I'm going to move the h away. So we're undoing what's happening to that b. So I'm going to divide by h. And I like showing divide that way just because otherwise the little division symbol gets a little messy. Divide by h. H over h cancels. So I have b alone. This is good. But on this side, you're like, oh my gosh, what a mess I have over there. But that's okay. We're okay with a mess as our answer in these problems, which is really confusing and strange because we're not used to it. We just rewrote it so b is alone. And that's it. It's done. B is alone. Now, some of you guys are like totally like, you're my why people. Like, why are we doing this? It seems so unnecessary and so not helpful. I will tell you guys, this is something that kind of goes across departments. So like, when I was in high school, I was debating between math and physics for college. I love both. And physics, using a formula like this and being able to solve it for a particular variable, that's something you're gonna have to do so many times, is getting that variable alone. Because we'll keep solving for b, and it's a lot easier if that formula is already written that way. So being able to rewrite formulas is something we have to do in this class, but then it crosses over to science, it keeps going on your math cycle. So just know that it's not gonna stop here, but being able to solve for that variable is something that's really gonna be helpful as you guys move along. So today it probably does not seem all that useful, and I know that, but this is kind of like those building blocks of getting you guys to wherever you want to be when you're done, or at least getting you through high school or getting to that point. Yep.
All I see with that is you pretty much take whatever happening to B and put it on A.
Yeah, you're moving it, yeah. So in this case, it does work that way. So this next one's a little bit different that way. So I'll show you that, because it's a good point. So he said, basically, whatever was happening to B, you do all the opposite things to A, and that's true in that problem, because they're so straightforward. This next one's a little bit more complicated than that. So that's a great observation. It works a lot of times, and that's kind of what's going to happen here. But this time we want to solve for y. Now, if you want to make a really boring list, you could count how many times I'm going to tell you this year to solve for y, and it's probably about 1,000 this year. Like, we solve for y so many times. So I'm going to tell you guys, you'll probably get sick of hearing me. We have to get y alone, we have to get y alone, something we do a lot. So here's our first time of getting our y alone. So we're solving for y, which means, again, translate to get y alone. So when you see that, that's what they're asking you to do. So again, we have to undo what's happening to y in this problem. And we'll get to do a little bit of simplifying. And so it's a little bit less straightforward than that last one. So we still have to remember our steps of solving though. If these were all numbers and not variables at all, we'd still want to, there's no parentheses, there's no like terms to worry about, so we don't have to worry about those steps on these. But we want to undo addition and subtraction first. So we want to get y alone. What's being added or subtracted to y? Yeah, go ahead. The 3x. So we want to move that 3x away because it's being added to the 2y. How do I move 3x to the other side? Yeah, go ahead.
Subtract.
Yeah, so we're going to subtract. Oh, I didn't have the right thing on. Subtract 3x from this side, and I have to do the same thing to the other side of the equal sign. Now careful here. The 3x's cancel. But is that just 6x on the right side? Sorry.
No, it's 9 times negative 3x.
Close. Yep. Yeah, those aren't like terms. We can't put those together. So this is really like I'm taking 9 and subtracting 3x from it. So on the left side I have 2y. Over here I'm just going to write 9 minus 3x. I can't put those together because they're not like terms. Yep. You want to tell us what to do next?
Yeah.
Okay, just hang on 1 second. Are we okay with that first step? So we can't put those together, like that's an important part of this. All right, go ahead, Reagan. What do you want to do next?
We want to divide by 2 since y equals the y alone and we for the 2.
Yeah, so y is now being multiplied by 2. Or it always was being multiplied by 2. So to undo that, we have to divide by 2. If I divide by 2 here, dividing is a little bit more complicated than multiplying though. I have to divide everything by 2. So I'm going to make a big division bar and show divide by 2. Now, 9 and 3 both can't be divided by 2. So since I'd like to avoid fractions or keep it just this way, I can do this. That is perfectly fine to leave it that way. If it's driving you crazy that there's still a fraction, you can divide those both by 2. So 9 divided by 2 is 4.5. 3 divided by 2 is 1.5. You could write it this way if you wanted. I don't know. I don't know which, like what you like best here. All of these are fine. I accept any of these three answers. But we have to show that we somehow divided by 2. Okay? We're going to flip the page over and do one more example, and then we'll do whiteboards for a little bit to make sure we got it. Yes, and then logged off. Yeah. Par for the course. Got it. Oh. 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 Yeah, well, it's maybe helped, right? Okay, so let's look at this top example up here. They want us to solve for C. It's a really similar problem to the one we just did. So we want to solve for C, so not totally different from the problem we just did. You guys want to think about what you want to do first. I'll give you guys a second. We'll get started here. If you want to wait, go ahead. We'll have plenty to do on our own on our whiteboards. So getting the C alone. And they just specify what they want alone. So if you're wondering how, oh, sorry. The wording is really weird, I just realized. Because I think I just said that wrong. It said, I didn't read this very quickly. Or I read it too quickly, sorry. Rewrite the equation so B is a function of C. I'm lying about what they want. This is a really weird way to explain. They just want you to get B alone, so that B is a function of C. So they want it to be B equals, sorry. I read it and just saw the C at the end and assumed that's what I was supposed to be doing, sorry. The book words it this way. I won't ever word it this way on a test, because I get confused, obviously. So they wanted the B to be alone. I apologize. Some of you guys are erasing because you're already done. It's good practice, go both ways. Either one's fine. All right, so we're gonna get that B alone. Sorry about that. So changing gears, what's our first step? Go ahead, Claire. Yeah, move that 12C away. So we want to get this B alone. So we're going to move this 12C away, so I have to subtract it from each side. So I'm left with 6B. And again, those aren't like terms, so the 9 and 12 aren't the same term, so they don't both have C's on them. So I'm just going to write 9 minus 12C. And then to get B alone, we're going to do what? By, yep, so we're going to divide by 6. Now this one's a little bit unique, because this one we actually can do some simplifying. So let me show you guys what we have right now. So there's a few different ways you guys can write this. This is not very simplified. Does anyone see how we can simplify it? Anything we can do with those? Yeah, go ahead.
You could, excuse me, sorry. You could divide all of it by 3.
Yeah, all of them are divisible by 3. So that's the one I like the most. So like, I would probably say this is, if you divide them all by 3, so I divide all of these guys by 3, I get 3 minus 4C all over 2. That's great. You can leave it that way. Now, if you wanted to write it the way we did on the last problem, we kind of broke it into 2 fractions. I'll show you guys another way you can write it. You could do 9 over 6 minus 12C over 6. But those 2 can be simplified. Do you see that? So 9 over 6 can become, yep.
Why can't we just put the 9 minus 12C over just 1 6? Why does each one have to be their own fraction?
Sorry, I guess I don't understand. Which?
Like, he's asking why you are both putting them under different 6s when you can put them under.
Because now we can simplify those each.
Oh.
So I'm fine with you writing it this way. It's just this one's not as simplified enough. So this is one version of the answer. 9 over 6 becomes 3 over 2, right? But then 12 over 6 can actually become 2 over 1 or just 2C. So either answer is fine with me. And you might say that this one's a little more simplified, but I kind of like the single fraction, but either one is fine with me, but they're both simplified. Okay? So we're going to grab whiteboards so we can practice a little bit before we get into word problems, because obviously those are more complicated. So if this half of the room wants to grab whiteboards, that would be great.